Welcome to Train Signal. I'm Ross Bagurtis, and in this video, other data link layer protocols and the physical layer, we're going to take a look at wrapping up all the technology and terminology we've talked about throughout the OSI model. So let's start with some of the rest of the data link layer protocols that are in our modern networks. So the data link layer protocols, some of these we've talked about so far. Ethernet. And Ethernet comes in multiple varieties. The IEEE, the Institute of Electrical and Electronic Engineers, 802.3 specification is for Ethernet. And that spec comes in different varieties. We have a 10 megabit spec, we have a 100 megabit spec, a gigabit spec, a 10 gigabit spec, and there's more specs to come that are used over both copper wiring and fiber optic cabling. Wireless Ethernet, we're most likely very familiar with. And we've probably heard the letters and number combination 802.11a, B, G, N, or AC. AC is the brand new one that's just starting to gain popularity. Here, wireless Ethernet can operate at 11 megabits per second, 54 megabits per second, and even higher than that, especially once we get into the N and AC technologies, where we're actually using multiple radios in our wireless equipment to transfer information back and forth. So we have Ethernet, wireless Ethernet, both are controlled by IEEE. We have point-to-point protocol. So point-to-point protocol is used over serial links. We call it PPP. If you're old enough and you remember using maybe connecting to a bulletin board service in the 80s, possibly an internet service in the 90s, you remember using a modem, and those modems were pretty darn slow. As a matter of fact, it wasn't until the mid-90s where we got up to the 56 kilobits per second speed over a modem. Well, why am I talking about modems here when I'm talking about PPP? Well, when we used a dial-up modem, we actually used PPP as the data link layer protocol to send traffic over that modem. In that same way, we build bigger network connections using serial connections that are called T1s and T3s. Now, those T1s and T3s have a pretty ancient history. They were actually developed, surprisingly, in the 50s as the first mechanism to transfer telephone calls across the country without losing information. To give you a little sidestep on that, back in the 50s, when you made a long distance phone call from New York to San Francisco, the quality of the connection was so poor, you may barely be able to understand the person at the other end of the connection. They figured out how to convert the analog signal of the phone communication into a digital signal so that they can send that over long distances. And the difference there is that digital signals are much easier to clean up and repeat than an analog signal is. In the 50s, actually, we built this T1 technology to transfer telephone calls over long distances. And then in the 70s, 80s, and 90s, we began then to use those T1, T3 technologies to connect data networks together across long distances. At least in a production environment, we use those connections for our network connections. So we actually kind of bastardized this telephone technology to use it as a data network technology. The big reason we did it was that the wires were already in the ground. We just had to put a different endpoint on it to make it transfer data instead of telephone information, phone calls. So point-to-point protocol is responsible for all of this up at the data link layer. So the data link layer is going to use PPP to transfer information over T1, T3, and whatnot. And there's a variety of speeds for the serial links, all the way down to 600 baud, which is 600 bits per second, and all the way up 44 megabits per second and higher. The reality is that PPP links over serial connections are becoming much less common nowadays. We're moving much more to Ethernet as our primary mechanism to connect facilities together. Other technologies here. Asynchronous transfer mode. We use ATM over fiber optic cabling. Again, now we use ATM to transfer phone conversations over long distances over fiber optic cabling. So back in the 80s, the first fiber optic telephone network got installed across the country, and they needed a new technology to transfer those messages, so they use asynchronous transfer mode now to transfer voice calls over fiber optic cabling. It's much more efficient than the T1 because we can get a lot faster speeds over asynchronous transfer mode. We actually used ATM in data networking in the late 90s, early 2000s quite a bit. And that was until Ethernet became so popular and we kind of abandoned the layer 2 technology of ATM in data networking in favor of Ethernet. And the big reason there was that we have to support Ethernet for our end users. Ethernet's a very common technology, very easy and versatile. So we start to use Ethernet as our WAN links over fiber optic instead of ATM. So ATM is a bit antiquated as well. Data over Cable Interface Specification, DOCSIS 3.0. This is a specific protocol to send data over a coax cable. So it's a mechanism so that we can have internet access over our cable TV line. You should be noticing repetition in what I'm saying here about how data networking evolved out of the telecommunications industry. So on the telephone side, we have telephone companies using T1s and T3s to transfer telephone calls cleanly and neatly, and then later on they adopted asynchronous transfer mode to do that. And guess what? The network engineers came along and said, "Ooh, we want to use that too because you have the wires in the ground." So they went and they kind of borrowed the technology because the infrastructure was already there. Network engineers didn't have to build a new infrastructure. Same thing with cable. In the 70s and 80s, we saw this huge cable TV infrastructure installed and maintained in order to deliver high quality cable TV service. Well, they wrote this specification then that just allowed the same cable to be used in order to send data network information over the cable TV network now. So we're repeating this again. And we're going to do it again here with DSL, digital subscriber line. Here, we're going to use the infrastructure of the two wires that come into our house that run our telephones, and we're going to put different endpoints on the end of those two wires, so now we can send high-speed data network traffic across it. And I think now we're up to about 12 megabits per second over those two wires at a maximum. It's possible it's closer to 6 megabits per second, but either way, we get relatively fast speeds over these two wires that are coming into our house. So as we see technology evolve, we're going to see a repetition of reusing infrastructure over and over and over again. As a matter of fact, if you take a look at DSL again, this is kind of an interesting fact about DSL. Back in 1876 is when Bell came up with the idea and got a patent for a two-wire telephone. And guess how many wires your telephone has today if you have a landline installed in your house? 2. So we are literally using technology that's nearly 140 years old. We're using an infrastructure that has a 140-year lifespan. That is obscenely impressive when we're talking about data networking. We're using 140-year-old technology to actually transmit data at high speeds. Something that Alexander Graham Bell had absolutely no clue was possible when he developed this initially.